All right. Okay, it's about that time where we get cranking. So, welcome to the TLS Working Group, our second session Friday morning. Yeah, we're almost done. So again, this is Friday. If this is the first day you're here, note thee well, gangman style. Basically, you're going to be recorded. If you have IPR, you need to disclose it. There's some links. BCP, this shouldn't have been the first time you've seen this week. We got Jabber Scribes already. Thank you very much. We got minute takers. Thank you very much. The blue sheets are circulating. Please sign them.
Hey, Rich, you've been volunteered as Jabber Scribe.
All right, cool. Reminder, state your name at the mic for the scribes in the minutes. And again, let's keep it classy. So we did Tuesday's agenda. So the slides I uploaded are version 6. This basically all the moving around that we did. So this is what we did on Tuesday. No need to agenda bash that. This is Friday. Basically what we decided to do was put the technical meat at the front. That's probably most pertinent maybe. And then go from there because we are kind of double booked with TCP Inc. guys. So we're hoping maybe we can finish early and then everybody can pile over there. So I guess we're going to start off with some slides from Ecker on DTLS, and then maybe Martin Thompson can do some slides on some optimization. And then we have other working group draft, the DNS validation chain extension draft. The Nick has a presentation on some delegated credentials, and then you're on. This mic's not working. Eat the mic. All right, cool. So unless there's any agenda bash, great, let's do it. Oh shit. What? Well, now it's gonna work.
Guess I can just do whatever I want. All right. Okay, so I'm Hannes Schofenig, and Martin will also be Hannes Schofenig later. I think Hannes is now decided to run back to Austria. So okay, huh? You know, I'm not sure it's long for Hannes.
Yeah, he won't think it's daunting at all. Trust me.
He was telling me that he was going to do a 440-kilometer run at some point. So that seems long. This is sort of a public service announcement. When we first started doing TLS 1.3, I kind of had the intention that we would just like have like, you know, an appendix at the end that was like, here's how you do DTLS 1.3, and kind of like there was some contention from like the time of the people who do this work, and also trying to do a little more complicated than we were hoping. So, you know, we've been bearing this in mind throughout the entire design process, but we decided it'd be easier just to update the DTLS draft rather than trying to like merge everything in. So almost all this work, so as I say, this is a public service announcement. Hannes wrote a new draft that updated the DTLS draft with some help from us, from Martin and myself. And he just isn't here. So we're not going to ask for adoption here. This is just a briefing on where we are and where we intend to go, so people are aware. Next slide. So as before, DTLS is a delta on TLS. So it's like really the TLS spec, and here's how you do DTLS. And we still present it that way. We made a few small sort of, so mostly this is just adapting DTLS to TLS 1.3. Along the way, there are some potential improvements, some of which are just flat improvements, some of which are kind of necessitated by the structure of TLS 1.3. And also there are some suggestions that people made along the way that we think maybe we should look at cleaning up. And this has been informed by at least the implementation experience of DTLS 1.3 in NSS. We have sort of a prototype version which we're afraid to turn on, and I think also Hannes' experience in embed. So it's not completely divorced from reality, though not entirely grounded in reality either. Next slide. What we've done basically is just mostly directly adopt the TLS 1.3 message flows and just stuff them into the DTLS formatting structure, namely with the extra sort of message overhead for the record index and the offsets and the fragments, that kind of stuff. From the sort of perspective of the state machine, the only real state machine change is the deprecation of the hello verify request, which was sort of the cookie exchange in DTLS, and replacing it with the hello retry request, which has a similar cookie, but it serves other purposes as well in 1.3. So we're just going to throw away hello verify request. There are a few subtle points about how you actually manage the interaction between 1.2 and 1.3 around HVR and HRR, which aren't quite clear in the draft, but we can get right.
Yeah, so Martin Thompson, you're going to talk about ACK? I
am.
Good.
It turns out these slides are on the internet, so you can download them. So like this was always our plan from the very beginning, and it's one of the primary reasons why a hello retry request actually has a cookie, because we wanted to make sure we could do a stateless exchange. Next slide. Wow, look at that. I just did that for you right now. No doubt, due to my lack of foresight, DTLS had an implicit ACK rather than explicit ACK, and the way the state machine works is that you send your flight, and then you wait for the first message from the other side of the next flight, or any message from the other side of the next flight, and that tells you that guy, because it's a lockstep handshake, that tells you that the other side must have received all the messages in your flight, and then you can just basically cancel your retransmit timer. And there's always some like shenanigans around the last flight being sent, but mostly it kind of worked. As I say, this is a little simple-minded and maybe too simple-minded. It works reasonably well. Actually, it works extremely well in situations where there's no packet loss whatsoever, and therefore you're not really in a datagram transport. It works acceptably well in situations where there's sort of very modest levels of packet loss. It's a little tricky to implement correctly, especially, as I say, the shenanigans around the last flight and the 2MSL hold down timer and that kind of stuff. But it gives you like extremely poor congestion feedback, because what you get told, and in fact, poor congestion properties in general, because like you don't know what packet, when you don't receive like something from the other side, you don't know what got lost. And so basically you wait for the timer to expire and you're like, I guess like, I'm the server and I sent server hello and like 19 packets full of like certificates and certificate request, and then a finished, and I guess you didn't get one of them, so I gotta send them all again. And that's like pretty goofy. And also it also doesn't give you any real feedback about congestion at all. In particular, so when we started looking at quick and TLS integration, one of the like main things people were sad about was that if you just sort of did the naive thing and layered, a transport handshake on top of DTLS, you like basically burned a whole round trip learning essentially nothing about the channel, because you didn't know how long everything took, you didn't know like whatever the packets arrived in, you didn't learn very much. And this is especially true if you had any kind of packet loss where like you just had to keep retransmitting, and it was really goofy. So all those reasons like might not be reasons to disturb the status quo. They're just sort of reasons to be a little sad about it being goofy. But then it turns out that we disturbed this nice 4-message handshake by adding new session ticket at the very end of the handshake, and new session ticket has like nothing that confirms it. And so it became clear if you wanted new session ticket to work and you want a presumption to work at all, you had to have some way to say, like, I didn't get your new session ticket, or I did, or whatever, right? And so the natural response to this is to sort of say, well, stop being so goofy and stop trying to do implicit hacking and just do explicit hacking. And so at the solution we've adopted in this draft, we've adopted the worst possible version of this, which is to say an empty ACK message, which just says, I got your thing, which is like only like about 1.5% better than the thing that's like the first message of the previous handshake. I'm almost certain this is wrong. I mean, we need we want some sort of timestamp and sacking and whatever, so that we solve these other problems about congestion feedback and handling individual packet loss. But the details are TBD, but that's the direction we're intending to go down. At least I'm intending to go down. I think Martin's on board with that. We have to decide how good a job we want to do here, but probably something. Next slide. So the other sort of problem we had to adapt to is this key update thing. So in DTLS, you use DTLS basically has explicit key changes based on the handshake, just like TLS 1.2 did. And with the introduction of and so it has this epoch bit or epoch counter in the record layer, which tells you which handshake, which handshake generation the message came from. But the only real purpose of the epoch counter is to allow you to disambiguate, messages which get reordered with respect to the handshake. And so it's not really that important. But the problem is that when you introduce key update, now you have a situation where like key update isn't reliably delivered, so that's goofy, and it's not locksteps, that's goofy. And so you must say, well, but epoch bit's here, so like all I have to do is like when I receive, a new epoch, I'll just process. Anyway, so you might think this is all going to work properly, but we have another problem too, which when you look at the handshake, you say, which epoch bits do we set for things? And so it's pretty clear, like the client hello has to be 0 epoch, that makes sense. And the server hello also is 0 epoch, that also makes sense. So when you switch to encrypted data, that should be 1, that also makes sense. But the problem is there's this confusion between the first flight of early data, if you're doing 0 RTT, which should be 1, and then if the server says, I don't want early data, then what goes in this finished message from the client? And you might think 1, you might think 2, you might think 4, or something like that, right? So we screwed around with this a bunch of times, and like the amount of sort of weird, goofy logic in the code that was like, okay, move the epoch up and move the epoch back, and like the kind of stuff like did not like make anybody happy. And so Hannes, and so we were very pleased to see this draft from Hannes come out, and Hannes had adopted, a simple-minded but actually a quite clever approach, which is let's just like say that like the individual handshake flights have specific epoch numbers, and then you know exactly what you have to do at any given time. And so there's like a table in the draft that says like these messages have these epoch numbers. The table is actually currently wrong, but we can fix that. What's wrong because it's based like draft 16, and so like it thinks you still have to have early handshake data, which you don't have anymore. That removes all the ambiguity and just leaves you with a state where things are okay, albeit at the cost that you end up skipping epochs occasionally. But that doesn't cause anybody any particular pain. So we think this is probably the right way to handle it. We updated our implementation to do this, and it's much, much easier. But if this seems like gross to people, like, you should mention it at some point.
I will cut anyone who changes this. This is really so good.
Martin was the person to do this. So anyway, that's how we plan to handle this. Next slide. Right. So second, as I say, we have the second sort of epoch question around key update. What happens if so first of all, like you say, what happens if key updates get lost? Like how does the other side know it should be like updating? And second, you say, wait, this information is already in the epochs. Like why do I need it for the key update? So the first pass attempt at this was like, let's just not like send key update, and we'll just use the epoch entirely as the only thing we use. So that does kind of work. But if you want to like read my review of Martin's code where he like did this, you discover something that he had to do that made me sad, and I think made him sad too, which is, let us say you're on epoch 0 or 2, let's say, and someone sends you something with epoch 3. So it's not a good idea to update to epoch 3 until you validate that like actually that message wasn't some like totally unverifiable message that happened to have 3 in the epoch bit. So you got to be like, well, I've got like my old keys, and then I've got my new keys. I'll try this packet with the new keys. If it works, then I update the epoch bit. And if it doesn't work, then I just like ignore the packet. So that's like not really awesome. Awesome. See.
Sorry.
So, and also like what happens if like someone sends you, you're on epoch 2 and someone sends you epoch, 62,000. So like, are you supposed to compute 62,000 keys in the future and then like whatever? So that's like not really ideal either. So like this seems like a part that's like a little bit of a hard hat area, and we're trying to figure out what the right answer is. And I think Martin and I are currently debating this topic. I think Martin leads towards doing this, but only like allowing one outstanding update. And I think I lean towards using the ACK to make the key update thing work properly. Multiple possible options here. Next slide. To preview that, the way you would actually make the way you do the key update thing if you wanted to use ACK is you'd say you can't start sending with the new bits until you've received the ACK. Okay. There's some other sort of smallish issues. There's this extremely odd, one's complement, version number stuff in DTLS that for some reason, like when we did this, we thought it was like a really good idea to make it like not possible to confuse DTLS implementations and TLS implementations. This is like a horrifically bad idea, it turns out. Had we not, but anyway, we did it. Now that we have supported versions, it's not clear that we need this at all anymore. So what should go in supported versions as opposed to going into client hello version? And I think the answer is pretty clearly like the normal TLS, like unmasked version number. There's been a lot of complaints over the years about how long like the DTLS record header is. I think Martin's gonna talk about this in a minute. We have like the 5-byte header, and then we have like the sequence number, and it's like an 8-byte sequence number plus epoch, and it's like, you got to have like a lot of packets outstanding before you can't disambiguate things with only about 4 or 5 bytes. So that's a little grim too. So I think there's some question where should we try to reduce these things? And DTLS, unlike TLS, doesn't have this huge installed base of middle boxes that do enforcement. And so it's probably the case that we can just make as many changes to the record layers we want without things getting too dangerous. Now, if we do shorten the sequence number, that leaves us room to lengthen things. And they've been repeating, the number one most requested feature for DTLS is like, why don't you have a connection ID? Like, you like the 5 tuple is a huge pain in the ass, and there's all these sort of stuff in the draft about what happens if you start receiving packets from a 5 tuple that you don't really recognize, because and so a lot of people ask for a connection ID, and so I think there's this draft facade perhaps on this. So at least we should take a look at whether or not we should add a connection ID, perhaps as an optional feature. I don't think I want to have it as a required feature, not because I'm, partly because of sort of the privacy issues that have been raised by the quick connection ID, but also because I don't really want to bloat there are lots of situations where you don't need it. I don't want to bloat every packet with like 8 bytes. So these question marks obviously indicate that maybe people have some other things that they'd like us to do. That would probably be a good time to kind of raise those things. Next slide. So where's the timeline? I'm explicitly not asking for any kind of adoption here. I don't think we're ready for that point. What we're planning to do is we'll update, there's this individual draft under my name, but I'd say Hannes did most of the work. So we'll update that to match draft 18 or maybe draft 19. In fact, I don't think it should be any different between those two. And we'll then do some test implementations in NSS and embed to sort of like try to sand off a few of the rough edges. Hope Hannes will do embed, we'll certainly do NSS. And then we'll probably come back sometime, between now and Chicago, or worst case Chicago, and ask for working group acceptance of this item. So I guess, does any of this sort of sound gross to people in a way that is like so gross that you think you want to like throw a flag now, as opposed to later? Anybody want to raise any other things they think we should take into account as we do this? Anybody want to help those kinds of things? Now would be a great time, though you'll have plenty of other opportunities. All right, then.
Friday morning, very
Yeah, really.
exciting. All right, now we have, no. Let me find it. Where is it? DTLS. This.
So Eka already covered some of the points that are in here. So there's a bunch of people who are unhappy about certain properties of DTLS, particularly when they start using it in earnest. And Hannes asked me to sort of go through some of these things. Let's just go ahead. So that's an RFC that I had to look up. It's a discussion of the requirements for using DTLS in IoT. The idea originally was to just simply use TLS or DTLS as it was found in the wild, but people obviously found a few problems with that. And so we've had a bunch of things come up. The most interesting one being this notion of some sort of connection identifier. And I'll go into a little detail why that's the problem. When you have a device that's idle for long periods of time and you're using DTLS, when it comes back from its little nap, things can change. And particularly in cases where you have a NAT, you might get different NAT bindings. You might even get an entirely new DHCP lease. And the way that we deal with that in DTLS today is we go, too bad. Make a new connection, do the handshake again, and off you go. But we're talking about devices that don't have a lot of power, and they don't really want to go through an entire handshake just to send the one packet that they wanted to send. And so we find that we need, in these circumstances, we would benefit greatly, in any case, from having some way to identify a pre-existing session that you have with the server, so that the server can say, oh, hi, it's you again. Server client, reverse the roles, same thing applies. And so we've actually had a couple of drafts propose this in the last, I don't know, week. It's odd that it's all coming together at the same time, particularly when we're having the same sort of discussions in Quick. Yeah, even PSK handshakes hurt in some of these situations. Having to run SHA-256 a gazillion times to get a TLS handshake working. Don't ask me how many, but Antoine actually counted it. It's not pleasant for these devices. And probably the biggest thing is you have to send a bunch of packets and worry about retransmissions and all sorts of other things where that's just kind of impractical. So these are the requirements that Hannes has worked out. Like Eka said, it'd be really good if this sort of feature were optional, so that we're not paying the price for application contexts where it's not really necessary. And I guess the last point's the sort of killer point. Providing a correlator across sessions between different points of network attachment would be sad making, given all the effort that we've put in to do things like MAC randomization and whatnot. So there's, I think the Fossati draft talks about a technique that they're proposing for using hash-based one-time passwords keyed off an exporter. We can talk about the exact nature of that particular technique, but that seems to have some of the right privacy properties. Next, I think we're almost there.
You have a slide.
There is a slide. So it's pretty straightforward proposal. You slap an extension in your handshake. If the server's okay with that extension, you add a field to the front of the header in the unencrypted part. That would not be authenticated on a per packet basis. It wouldn't go in the AAD or anything like that. And the proposal here has two options, a fixed identifier and one that you would be able to change on as you saw fit, based on just simply rehashing and going again. Personally, I'm not sure which one of these we want to go with. The second one requires that you have a table of all the connections that you have open in order to sort of recover the state.
Right. I mean, so the difficulty here, I mean, when we looked at this for Quick, right, the difficulty here is that the streams get crossed. So there are two kinds of situations where you need this, right? One of which, I guess three, but we'll just talk about two for now, right? The first is when you are mobile, and the second is when you have like a rebinding event, right? And so if you're mobile, if you
really wanted to change, right?
So because my point is, yeah, if you have a sequence of if you have a sequence of identifiers and you know what order to use them in, and you know you've changed, then you're golden. You just change the next one, right? But if you don't know you've changed, then what happens is you omit the old identifier and the new parameters, and now it's too late because now you're just hosed, right? And so the question is, and so we're gonna have exactly this problem quick. Is there any way to like not have that happen? And I don't have like a bunch of good answers, but so that seems like the challenge.
You do have to know that things have changed.
Ben Kadek, something maybe controversial, maybe just ignorant. but what do we have in terms of use cases where we need this and you can't just use quick?
This is deployed code. This would be a minor change to deployed code, as opposed to, hey, let's just implement this thing that the IETF is just starting work on. I think that's it. Oh yeah. I think that first question is answered. I think Echo proposed on the list that once when you negotiate this extension, it's only when you switch to encryption that you slap this stuff in. And that's pretty straightforward, and I think it addresses the use cases that people are concerned about. The question about 32 bits is an interesting one. We've had a bunch of discussions about whether this is only for use in sort of constrained device environments where you have the potential for NAT rebindings, or whether it's something broader and you have to deal with situations like in Quick, where you have large server farms and you need to route to the right node within the server farm. 32 bits would not be sufficient in that case. The 32-bit identifier that's proposed in this document requires that someone have a grand table somewhere of all the connections. That may not scale particularly well. The designs that I've heard for the connection identifier and Quick take into account more constraints on the solution space.
I mean, given that we're bothering to negotiate this, like this seems like something where you could have a variable length field.
Right. That's a
I mean, when I say variable, I mean negotiable, not
Negotiable,
per packet
yeah.
variable.
Yeah.
I mean, you could do a variable too, I suppose.
Yeah.
But, that seems gross.
I would like to have a connection identifier that is 256 octets long. Would be insane, but
yeah,
you could see that happening.
So what is the? I guess did Hannes brief you before you came here? So what is the proposed disposition of this work?
He did not brief me on that aspect of it. I think we need to discuss it at this point. I don't think we're at the point where we want to agree to a particular solution.
Yeah, I mean, as I said, this is probably the most requested feature that and probably I think our biggest mistake. We did details in the first place. So so I certainly think we should do something here. It sounds like they want to have it for 1.2, so we have to do it. So we need to, but it seems like we can
doing it generically seems pretty.
It seems like we can define the mechanism perfectly well, and then figure out how to graft it onto 1.2 and 1.3. Like, I guess the question is, can we address the privacy issues in a sensible way? And that brings us back to Quick, which as far as I can tell is exactly the same privacy issues. So, I guess I don't see how to. I guess two things. I don't see how to get away with worry about the privacy issues, and two, like I don't see how to build a system that's multipath like Quick is without solving this problem. So I think we have to. We're somehow the security area is going to solve this problem.
Subodh Anger. So it seems like in DTLS 1.3, we have an opportunity to start off with requiring clients to always support proof of work-based systems. So something like Eric Nygren or there was a draft out there proposed for TLS 1.3.
Puzzles, yeah.
Yeah, puzzles, that's right. So it seems like we have an opportunity to require clients. So if a server knows that clients are only speaking TLS 1.3, then they could rely on this behavior. So that's a meta comment.
Lorenzo Colletti, I'd like to point out if you need to deploy Quick at any sort of scale, you need to be able to do hardware load balancing for the connection ID. And so usually a fixed size is a good idea for that. If you sort of negotiate something, you might end up negotiating something that the hardware doesn't support, and so basically falling back to immobile Quick.
Yeah, so the strategy I had in mind there was that the client would express a range of sizes that it was happy to use, but the server would pick.
Do we expect servers to pick different values? Because if
No.
we basically only ever go to 64 bits for everyone and everything else withers and dies, then we have essentially dead code. But you know.
Yeah, that's a point. So for the use cases that the folks putting these drafts together had in mind, a very limited numbering space is totally sufficient, and that saves them. Yeah, a few options would be fine in that case. So if we said that we had the 4-octet version, which would address the use cases here, for those cases where you have endpoints that can have tables internally and so forth, versus the sort of quick scenarios where you have globally distributed data centers with load balancers that need probably a significant amount of entropy in there. 64 bits in quick is actually kind of maybe not enough. I know that people have been asking for 128, and it may actually be that more makes sense in other circumstances, but certainly that sort of larger size is necessary once you talk about global scale stuff. So there may be a handful of options.
That was the last slide just to show the implementations they're working with.
That's it. Yeah, there's people who want to do this, right? And we want to solve the problem for quick as well. That's kind of
I think that since Hans' slides didn't ask for working group adoption, I guess we're not really going to consider that at this point. The idea is that this draft can be revised to inform the decisions that you guys make, and that's probably the best plan, right?
Yeah. So yeah, Hannes' slides actually cover 2 drafts. The other draft actually talks about a bunch of other things that I think will inform the design of DTLS 1.3, as opposed to anything that we're going to need for the immediate term. But this is the issue that I think we need to think about.
I'm looking around, is Ian Sweat and Donna in the room? No? Okay, we're gonna need to I think form some sort of task force to address this connection ID crap in a more global kind of way.
Yeah. We've had discussions about this on and on.
Yeah, exactly right. But since it seems like now we have multiple consumers for the same problem, we should try to solve it once.
All right, thanks.
Who's next?
Melinda, you're up. Stop doing that. Okay.
Hi, I have to apologize. I've been down with a death crud all week, and I more unintelligible and inarticulate than usual. Okay, so I'm talking about the DNSSEC validation chain extension draft. So just by way of an update, let you know what's going on, and ask for some feedback on a couple of open questions. Okay, next slide, please. Okay, for those who aren't familiar with the work, the basic idea is that we're going to deliver an entire DNSSEC validation chain in a TLS extension, the idea being that it's going to eliminate DNS round trips and reduce latency. So there's a couple of things that are open right now. Excuse me. There's a question about record ordering within the extension. Implementing and specifying the client certificate support, and then TLS 1.3. We believe that the document will be ready for working group last call prior to Chicago. So, okay, so the record ordering question. Basically, the validation order is not always possible because of the CNAME and DNAME indirection. But we need to specify what the server needs to use as the first RR set anyway. So Victor Duchovny, who I think is not here this week, has a couple of proposals. One is this is the easy one, have the server present the records in the order it received them from its own DNS server, and that's what the initial implementation did, because it's easy, or then collapsing everything into a single jumbo packet.
Hi, Paul Vargas. So I'm a little confused here, because if you have this is using DNS wire format, right?
Yes.
So you have all the information in the packet. It doesn't really matter. You just loop over every record and whatever validates you put in your cache until you have no more records left, or records that don't validate, and you throw them away.
Okay.
So I think the order should not matter at all. And I'm not sure what you mean with big jumbo packet, because I'm assuming that you're actually sending one DNS packet as a wire format in the extension. So it will always be one packet.
He's talking about RR sets and reordering them. I mean, I favor what you just proposed, but there's a.
Does anyone have an alternative?
No, not really.
Okay, done, solved.
Yeah.
It's like an IETF thing many times, to care more about presentation formats than actual semantics. So yeah, yeah. Okay, so next slide, please. Okay, client certificates. We haven't really done anything with that yet. Shimon Hook did have a draft with several other people providing background on client certificates in Dane. That has expired, but I exchanged email with him and he said that he's interested in continuing that work. So we don't think that's going to be a big deal in terms of putting the support into, adding support for the validation chain extension.
Yeah, so Martin Thompson, I think that talking about client certificates in the draft may just lead you down a rat hole that's not really worth pursuing.
Okay.
We do actually have the ability in TLS 1.3 to potentially negotiate the extension in the reverse direction from the client to the from the server to the client. If we need that capacity in the future, we can write another document that specifies how that ties together. It shouldn't be particularly hard once you have your document in place.
Okay.
I would advise avoiding that area entirely and simply concentrating on the server authentication piece, because we understand that.
Okay. Okay, fair enough. Yeah, just got a thumbs up from Paul. Yeah, I mean, there's limited use of client certificates anyway, and I'm not sure what the situation is with demand for Dane support. Okay, next slide. TLS 1.3. I actually, Richard suggested that we do 1.3 only. That is, yeah, that's not going to happen. I mean, it's a good idea. It's not going to happen because I've actually got to implement this. And one of the libraries I'm depending on is OpenSSL. I'm not sure when 1.1 will be released. I saw Rich here. And he's not telling me, okay.
Not telling us, soon-ish.
An announcement in a couple of weeks as to what the date is for when we'll have an implementation.
Okay, I mean,
So-
fair enough, but
So for remote LAN, that's in a couple of weeks, we'll get an announcement for when we might get something.
right. So we're doing a client-side implementation in Firefox, which of course is libNSS, and 1.3 is there. Right now, the server-side implementation is in Nginx, which uses OpenSSL. I'm not married to Nginx, but it's certainly easier to work with than some of the alternatives. So, I mean, basically, we're saying 1.2 and 1.3 at this point.
So I apologize. It's been a while since I read this draft. Do you think you're delivering both the DNSSEC chain and the X509 chain, or you're delivering the DNSSEC chain displacing the X509 chain?
In the latter, in place
Okay.
of
So in that case, I think the appropriate thing to do is put in a certificate message, because you use 6069 or whatever it is to say I would like to have DNSSEC certificates.
Okay, that's in response to the first question?
That's correct. Yes,
Yeah,
yes,
okay.
yeah. I think if you think they're backups, then there's no room in the cert message. It's got to go into EE. But if you think they're replacements, then it might as well go in the right place. And then the client, and then they have parity between client and server,
Okay,
which is nice.
okay, that makes
Am I
sense.
just totally confused? You're giving me the face like I'm.
Sorry, Paul, I'm a little confused because I can see where you would have a normal server with certificates, and then in addition you add the DNSSEC chain, and maybe 10 years from now we will never use certificates again, hoping. So maybe there will be a period where they both be used.
Oh well, no, I was.
Yeah, absolutely, but we won't be delivering the X5, the traditional PKIX 5280 chain in this extension. No.
No, I guess yeah. So all I'm saying is like there are two postures you could have, right? One posture is that the clients either accept DNSSEC or they don't. And if they accept DNSSEC, we send them DNSSEC. And if they don't, we send them S509, and we never send them both. And the other is you could say, well, maybe I have a special blue indicator that I show when I have a DNSSEC chain plus a 509 chain, and then you send them both. In which case you can't stuff them both in the same message, so they got to go separate. So I think it's purely a question of what you're trying to accomplish. And if you're trying to accomplish that this is DNSSEC and not 509, then it's fine to put it in cert.
Paul Hoffman, I definitely supported in certificate message. I haven't
Okay.
really figured out, I mean, I haven't read the latest draft, but in the first one, I didn't understand what any advantage of putting in encrypted extensions was.
To be honest, I didn't either, but there are the two options there, and
Yeah, okay,
So I'm
great. So
asking,
I see stronger, I don't see any positive for encrypted extension. I definitely see positive as a certificate. It looks like a certificate, smells like a certificate. I think that's where
It is a
people would expect to see it.
certificate,
So in TLS 1.3, the certificate message has extensions on each certificate down the chain. So what would probably make sense with this is to have this as an extension of the end entity certificate and not have a series of certificates. That's
yeah, I'm getting up. Yeah, he's Nick Sullivan. I'm not. So that's a good point. I guess the question would then be what goes in the EE cert. I see two problems with that suggestion, though maybe they're resolvable. The first is that it doesn't work at all in 1.2, so if they're saying separate for 1.2, and the second is that it doesn't. Then the question is like, is what goes in the EE cert that the extensions are attached to, and is that the regular cert, and what are the semantics of that? These are all resolvable questions, no doubt, but I just have to resolve.
Yeah. So Martin Thompson, if I understand how this works properly, you can have a certificate, a genuine X509 certificate, and the Dane information, or you could have exclusively the Dane information, or you could have exclusively a certificate. So that suggests maybe there is. Here's a potential design. In TLS 1.2, you send the Dane information in an extension, in a server hello extension.
Right.
Then you also use that extension to use the, I think it's certificate type. You could switch out. And so if you didn't actually have an EE X509, you could switch that out and say, I don't have an X509.
Okay.
That's like, might require a little bit of analysis, but that could work. In TLS 1.3, you would use the certificate extension field for the EE certificate, and you plop the Dane information there, and then you would again use the certificate type to switch it out depending on whether you had an X509. So you can have an X509 or nothing, and then you have an extension attached to that saying, here's the Dane stuff. And you would use the extension type that you use to negotiate the protocol that you have.
Okay.
Your assigned number for that. And that would work equally well for the client certificate because we have extensions there as well. We just don't know what to do with them at the moment.
Okay, so that's a win there. Okay. Thanks.
Ben Kadek. So we do also have this proposal for the raw public keys in the certificate message, which I'm not really sure I want to advocate for, but I'll just mention it.
Okay. Is that what you were going to say, Paul? Okay.
Yeah. So you can use certificate type to say X509 raw public keys or look elsewhere. And the look elsewhere is you look at it at an extension that contains the Dane response or the RR set.
How? Oh, yeah. Well, distribution. So the bare public keys would have no authentication whatsoever unless you have the Dane blob, right? So it needs to go there together, right?
Yeah.
Okay.
Yeah. So bare public keys can be used now, absent any of this Dane stuff, and there's some expectation that you have some other way of authenticating them, or that you're using. There's some tricky stuff when it comes to Sigma and analysis around these sorts of things, but essentially the raw public key is the identity that you're actually looking for in some cases. Same applies here. You could actually put the raw public key in the case that you are doing Dane stuff, but let's not complicate things too much.
It's actually worth noting, obviously, that if you don't, several of the Dane types obviously don't contain the key itself, right? They can contain a binder to the key, and so either you have to put that key somewhere, or you have to prohibit those types. I mean, that's just the physics, right? So. Yes, or you have to say we only do. I can't remember which types they are, but the Dane types that contain the public keys in them.
Right.
That's it.
Okay. Thank you. This was really useful.
Yeah, I guess why don't maybe the proponents of this and Nick and Martin and I and get together after this and sit down and just sketch out what the options are on a piece of paper, and then we'll know.
Okay.
Paul Hoffman. Actually, I request you put it on the list. No, I understand, but I'm just saying, I haven't been following the list because I keep waiting for TLS 1.3 to happen, and I keep being told, and so I just did a search on the draft title, there's actually been no discussion on the list. It's only been, I think, at least with that in the subject, it's only been announcements. So having this actually be discussed on the list, I think would be a lovely thing.
Yeah, yeah, obviously.
So there's one use case for this draft or this idea of putting a DNSSEC signed chain inside the TLS handshake that hasn't been discussed here, and this is about A records. So there's been discussion about potentially using a handshake in HTTP to coalesce connections and to be able to have two certificates. This is something in the earlier TLS connection we talked about, exported authenticators. And the requirement for HTTP2 to coalesce connections is that the IP is the same and that the certificate covers both subject alternative names. So is there any idea? So this suggestion, sorry, this draft seems to be oriented a lot towards Dane, but it could also be applied to potentially adding additional A records into the TLS handshake to enable the authentication of additional DNS records to allow sort of connection coalescing. And one change that would have to happen in this draft for this to happen would be the ability to put multiple chains in the extension. Have you guys thought about this or discussed this?
No, we haven't. I hadn't heard about this HTTP feature. Have you heard about it, Allison? It sounds like it's a different extension, to be honest. You know, it's something that we could talk about. This is, as I said, this is new information to me. But yeah,
Just from the initial reading of the draft, it seems like it applies to any DNSSEC signed DNS record in TLS, and this would be a potential application of this. But reading further, this seems to be applying mostly to Dane TLSA records.
Yeah, I mean that's really the context within which we started the work.
Don't go too far, Nick. You're up next.
Allison said.
Allison Mencken, I wonder whether, just in the interest of protocol design extensibility, we should have an identifier of the type of chain it is, and then people could define additional chains in the future that have different functions. That allows you to do more experimental things. We're really thinking the Dane case here, but
carry multiple chains within the extension. You know, I guess I need a clearer sense of the use case, but it's certainly feasible.
Paul, so the way I saw this extension was as just an alternative method of pre-populating the DNS cache in a browser. And if we're going to add a lot of semantics about what this extension data really means, we're going to change a lot of the concepts, I think. So
okay.
I would really say this is just a way of pushing DNS record into the local browser cache, and the browser has its own mechanisms and protocols to deal with, you know, when it's going to do a DNS lookup on what it has in its cache. I think if we're going to mix this up with other extensions, it's going to get really hairy.
Yeah, I mean, from a working group chair perspective too, I'd like to, we have lots of extension points that we can make. Let's get some done and get them out. And if you guys are deploying code, it makes it a little bit easier.
Yeah, Ben Kadek, I was going to say this in response to Nick, and then I sat back down when we heard that, you know, this is maybe not quite the right place to add the extra records, but I just want to note that in the TLS 1.3, the strict requirements on the certificate message is that the end entity cert is first. So in theory, you could just shove random other certificates that are not needed to build the original chain in there. But again, I don't think I would actually advocate for this, and a separate message type is probably, yeah.
All right, cool. Thank you very much.
All right, I guess it's my turn. Nick Sullivan, Cloudflare. I'm going to talk to you guys a bit about a proposal we made a while back and haven't updated yet, but haven't had a chance to chat with a wider audience about, called delegated credentials. Next up. So this is a new draft, but it's an old idea. And these are the authors. This is the initial spec. It's as written, it's more of a sketch of an idea rather than a fully fleshed out proposal. But there's a couple open questions that I wanted to bring up here. First, a little bit of motivation. In TLS and in most TLS applications, the private key is in the application that is connected to the internet. And from a security architecture perspective, this is somewhat troubling. Heartbleed was one of the major indicators of that. If you could dump memory in the application that's facing the internet, then you could potentially steal the private key, which is very valuable in this case. So the motivation for this is to reduce the exposure of these private keys. Well, there are other proposals to do that, but this is a way to do that without compromising performance. Next slide, please. This is your TLS 1.2 handshake. Lots of stuff going back and forth. Next one, please. This is a proposal, something along the lines of what the Lurk BOF was talking about last time, of being able to move the private key to another server and do that operation somewhere else. The problem with this is that it adds additional latency. Next up. So this can be a lot, actually, and to get private key security, you have the cost of potentially doing a transatlantic or across the world request, depending on where you keep your key material. Next slide, please. So delegated credentials. This is essentially a time-bounded key swap. We are taking the authentication private key and replacing it with something else. So as proposed, it's an optional extension advertised by the client, and the server replies with its own extension to the certificate, perhaps, containing a delegated credential. And this is a new key pair with a restricted validity period. Currently, we suggested 7 days. This is the lifetime of the session ticket key. It could potentially have additional constraints, such as if the certificate is valid for 10 different domains, this could potentially only be valid for 1. And then this key and the name is signed by the delegator's private key. In the typical scenario, this would be the private key of the certificate. And the key innovation here is that the certificate verify is going to use the key from the delegated credential instead of the key from the certificate. Next one, please. When receiving a handshake that has one of these delegated credentials, how does the client validate it? The certificate constraints still apply. So whatever the certificate is, in time, whether it's in terms of types of signatures or the validity period or extended key usages or whatever, those still apply. Revocation and certificate transparency, these still apply to the certificate, but not to the delegated credential. So the only thing that the server has to do is validate the signature on the credential and validate the additional constraints in addition to the normal keychain constraints. Next slide, please. The benefits of this are, I guess, pretty clear. The signing key for TLS connections is now short-lived. So if you have a compromise of your edge server or the server that's actually doing the TLS termination, then the compromise window is a lot smaller. It also allows you to have centralized control of TLS keys if you're doing TLS termination worldwide in order to get close to your visitors. This allows you to not have to distribute your key into different operational jurisdictions and legal jurisdictions. So you can split your edge operations team from your key management team. Next one, please. So there are several implementation options. This is the first one. This is a little bit more onerous on certificate authorities. It sort of changes the model of how TLS works. This one actually is a way to implement this idea without changing anything in the specification. But essentially, rather than having an end entity certificate, you get a constrained sub CA that matches that end entity certificate. And you have to convince a certificate authority to create one of those for you. But this has the major downfall of that clients need support for critical name constraints. And when you're validating this chain, this is really relying a lot more closely on PKIX libraries and them not having bugs. Which is, yeah, hard to do. Hard to assume that they're going to be bug-free. Implementation option number 2 is to use an X509 signed certificate to represent this credential. This is sort of a natural approach. You're taking a public key and you're signing it with another private key and binding it to a set of information. X509 is a format for that. And there's an RFC 3820 that's really geared to creating this type of certificate. And this is for proxy certificates, but this
Basically that.
yeah, this is basically what that RFC is about. But in this proposal, you wouldn't necessarily put it as part of the certificate chain. It could potentially be an extension to the end entity certificate in TLS 1.3 or an extension, so that you wouldn't necessarily just take this as it is as a chain and put it through your PKIX library, because it wouldn't validate, because your entity certificate is not a CA. It does not have the CA bit. So there is some sort of funky logic you need to do in PKIX to do this. You have to validate the chain normally, and then you have to validate the X509 as if the end entity certificate was its CA. And X509 has a lot of redundant data that we don't necessarily need for this. That's option number 2. And option number 3 is custom structure. If we just, in TLS, we know how to do sort of signed objects. This digitally signed struct is sort of an expired concept, but there are, if you think of the certificate verify message, we know how to sign things in TLS, and we know how to build extensions. So this would be a custom TLS structure in which it just has a certain number of fields, not before, not after, what the algorithm is. That might not even that might not be necessary. The server name for constraining also might not be necessary, but in any case, just in general, just a custom structure, it needs a name and a key to protect against unknown key share attacks. Next slide,
Then we
please.
can argue about what else to put in it, right?
Yeah, I mean, that's one of the downsides of this is I put up there as feature creep. We don't want to reinvent certificates. This is something that people tend to do if they want to replace X509 is, oh, let's throw some more things in this structure, and then you end up with a worse version of X509. So we want to avoid doing that. Security considerations. The first 2 are, I guess, positive security considerations. This allows you to more securely store your private key, and also allows you to use signatures that are not currently available in CAs, like ED 25519 or other signature types that are listed in TLS as valid, but are very hard to get from certificate authorities. On the downside, compromising a delegate or private key becomes more dangerous. So a single signature means that you can get one delegated credential, which means that you can impersonate the server for 7 days. Whereas currently, if you manage to trick the server, this is the Jaeger attack of a few years ago on Quick and TLS 1.3, is if you can do the million signature, or sort of the million message attack, and manage to get a signature, that really only gets you one thing in TLS 1.3 and TLS 1.2. In the earlier current versions of Quick, that gives you something that you can use repeated times. And in this case, you're elevating TLS to the status where if you can get one signature, it gives you a credential that you can use for a longer period of time. So that's a potential downside of this. And yeah, so that's the end of the presentation. There's a lot of open questions, but I want to get a sense of whether people think that this is a valid, interesting thing to do, and what directions we should go in building this out.
Yes, so I certainly do think this is valid, otherwise I wouldn't have worked on it with you. Sure. I think it's this last point you're raising is like super important. When we looked at this in initially in TLS 1.3, the reason what structure we have is because we were concerned about opting every client in the world into a delegation scheme which they had no knowledge of. So I think that whatever design we choose is going to have to come with a certificate bit that says I'm signed on to this.
Right. So yeah, I didn't mention that, but these last 2, if we do want to make sure that people have to explicitly opt into using this scheme, then this requires a change with the CAs, which is obviously among the tougher things to do.
Right. So I guess I think, you know, that does to some extent cut against these issues about the basic constraints, but on the other, because you have to do something. But on the other hand, I think that so I think we'll need some bit. But I think this is very interesting to look at. So thank you for bringing it up and being willing to talk about it.
Can I briefly respond to Eric as well?
Yep.
Yeah, so Subodh Iyengar, co-author. So we have that the extension, the client opts into this using an extension. Sorry, which was it?
Sorry, there are two concerns, right? One concern is the client says, I'm willing to accept this. And the other is that the CA says, the certificate from the server says, I can use the certificate this way. And the problem is if you don't, so that if you don't have the second one, then basically when Chrome and Firefox all turn this extension, then suddenly every website in the world which had a which had a PKCS1 Oracle now has a horrible problem.
Okay, Sean Leonard. So general comment, then a couple of questions. So I also agree. I think that this is interesting work and it should be pursued. So get that out of the way. So is this being proposed for both TLS server certificates and TLS client certificates for mutual auth?
Initially, we were thinking of the use case of server certificates.
Okay, got it. Yeah, because I think that there's a clear use case that I see for client certificates. So that's something to consider as well. If the question is, okay, what of these three options are the best? It strikes me that based on experience and running code out there, I am aware of several pieces of running code already for proxy certificates, including proxy certificates in Firefox. So option 2 strikes me as the most obvious and durable choice, right? Option 3 basically is just a certificate, except that it could well be designed or implemented incorrectly. And as bad as people may hate PKIX validation libraries, you have to do it anyway. So why not just reuse those code paths? So I'm much more in favor of 2 rather than 1 or 3, with the caveat that maybe you want the CA to authorize whether they want to allow delegated certificates or not.
Russ Housley. I think that we should pursue this. I think leveraging 3820 is a good thing to do. I think it'd be straightforward to define extended key usage that can go in the end entity certificate that says, allow this to sign proxy certs or not. And then a lot of that is taken care of. Both the client is aware of it, or the subject is aware of it because they asked for that EKU in their cert, and the CA is authorizing it by including it or not. So I think it kind of works with the current authorization and enrollment model.
Deb.
So I'm Debbie Cooley. I'm Debbie Cooley. What? Still Debbie Cooley. So NSA IAD, actually probably more from a DoD point of view. I think this is really interesting. I think it would be interesting to make it work for both servers and clients. We tend to do a fair hunk of mutual auth. We do also sort of want to see things as they cross the boundary. So I think this would be interesting. It would be nice to have it actually be correct, secure. Maybe a better way to say that, right? So I want this done securely. I want this to be secure. So I like the fact that you have to sort of opt into this, to have the client have to say, yes, I will, I want to do this, rather than to have it done on his behalf without his knowledge, which sucks, frankly. So I think this is interesting. I think, yeah, we need to be careful though.
All right.
All right, Ryan Sleevey. Yeah, so speaking with a bit of like the CA browser form policy hat on, I know that in the past there's been concerns that, you know, if using certificates in any way basically has to go through the CA browser form and they take forever, even slower than the IETF. There are a number of options that make this second method viable without requiring any form of ballot or change. So there are some carve-outs like the EKU that was mentioned, as well as for extensions that have a defined form that the CA understands. And so those allow you to go down that path of option 2 without requiring any sort of external dependency on CAs being permitted to issue a new thing. You still have the external dependencies of CAs technical competence in offering said method, which is a concern. Like I can't wave that one away. But I do want to say that the second option seems the cleanest given this space, especially with the notion of the server opting in explicitly. So there are ways you can do that without requiring any additional dependencies to take on.
Yeah, so Richard Barnes prefers number 3, but he did not give me rationale. So I'm just going to put that as a placeholder. I have summoned him.
This is Sanjay Mishra. I think this is a good proposal, and we were also looking at this draft among other drafts with respect to the CDNI for the HTTPS delegation from CDN, upstream CDN to downstream CDN. So one of the clarification question that I have is, in the event that the upstream CDN, which is where the TLS connection terminates, does that entity would have the authority to issue a sub-certificate, or that is something that has to be issued by the certificate authority? Because I saw in your slide that said that the work has to be done at the CA level, so I was not sure, who can issue the sub-certificates.
Right. So in number 2, the issuer of the proxy certificate would be the end entity certificate. So the owner of the certificate itself, whoever has had that certificate issued, not the CA. Though the CA would have to issue that end entity certificate with a specific bit that allowed it to opt into this type of construction.
Okay, then just a quick follow-up question. So in that scenario, when the end entity that has the certificate issues a sub-certificate, so that, let's say, from an upstream CDN to a downstream CDN, now can this downstream CDN, which got issued a sub-certificate, can it in turn issue a sub-certificate?
Not in this proposal, but it is in the spec for proxy certificates that proxy certificates can issue themselves proxy certificates. Yeah, I'm a little uncomfortable with having delegating their credentials one other layer, but it's not in this proposal.
Okay, thanks.
Front mic.
Kazuhoku, this is very interesting. Thank you for writing it. And regarding the implementation options, my preference goes to 3, because in RFC 7250, we already, changed how we interpret the certificate frame. So having some kind of an extension point at that level seems to be a clean option in terms of design.
Thank you.
Subodh Iyengar, co-author. I'm speaking with my Facebook hat on. As an implementer, I prefer option 3 as well. So in my opinion, either we should go with the closest thing to the current situation, or we should tear it all down and kind of build a new thing, which is easier to validate. Option 2, it seems like a lot of people are for option 2, but I think that practically when you implement this thing like a PKIX implementer, it is pretty clunky to validate these certificate chains, especially if you consider multiple cert chains and validation of this. The existing PKIX libraries, at least OpenSSL, doesn't provide a clean interface to supply these certificate chains down into the library and kind of get a result out. So there's a bunch of work that needs to be put in and the security model is kind of interesting, where proxy certs and proxy certs. So there's a bunch of edge cases there, which a new structure allows us to alleviate all these edge cases and kind of have a clean restart of this whole process.
I'm sure this will be the subject of a fun hum later in life, but just gathering input now. Thank you.
Yep.
Richard?
Gotta tell you what type of key.
Summons worked, apparently.
Sure. Yeah, sorry, we're debating the finer points of syntax here. So yeah, Richard Barnes from Mozilla. So yeah, I'm also going to hammer on the implementer perspective here. And the TLDR, what I'm about to say is strongly prefer 3. I could probably work with 1, and 2 is a very distant third. As Subodh said, we kind of, you go to war with the PKIX libraries you have, And the PKIX library I've got is one where you plug in, you know, an end entity cert, and it tells you what, and a name, and it tells you whether that end entity cert validates, you know, changed to a trusted root and matches that name. That makes the proxy cert option really awkward, because I think, if I understand the proposal here, the proposal is basically to have the delegator's cert, the next to last cert above, you know, the first one above the end entity, be the one that you're going to do the name checks and things against. And it would be a pretty...
No, it would be the end entity cert.
Well, then that yeah, come up and correct me if you need to, but like that I think my understanding here is that the intent here is to allow the holder of an identifier, the owner of a domain, to delegate, to basically swap out the public key that's in the certificate so that someone else holding a different private key can act on behalf of that domain. And not to delegate a name, not to delegate any other attributes of the cert, but to make a time-boxed delegation of that key to another key of that name. Sorry?
I wouldn't characterize it that way. It's an odd way to characterize it.
That's how I characterized it on the previous slide.
So this option number 3, where you define a minimal struct that says this is the key to which I'm delegating this, and this is the time box, seems like the simplest way to do that, because I can do my normal PKIX validation on the chain I got, and do the normal name checks I do on the end entity cert at the end of that chain, and then I can add a little bit of code that does the verification of this special thing, and you know, verifies that the public, and uses that public key to do the verification in TLS. So I think this is a much simpler approach in terms of integrating with existing valid PKIX libraries. I would be really, same considerations sort of apply to number 1 with the name constraint subordinates, to a slightly lesser degree.
Andrei Popov, Microsoft. So I do like the approach in general with delegated credentials rather than a round trip to, you know, a secure server across the, you know, the ocean. I think that's a better approach in general. With regard to specific details, I would probably prefer a standard format rather than like PKX format rather than the a custom structure, because we already have code that handles that, you know, just for that reason. And if any extension is needed, again, there is. It's all solved in the existing format, ugly as it is. Then the one thing that concerns me about this, because this requires changes on the client side, I'm wondering about the deployment model. So if you have an existing service that wants to use this, it looks like for the longest time, I mean years into the future, that service still has to have a normal certificate and do the normal PKI thing that we do today until all the clients that you care about have been updated to support this. So do you have any plans, you know, what's your plan for addressing that?
In general, if you want to serve TLS without having the certificate at the edge, then potentially you could fall back to one of these lurk type proposals.
Okay, thanks.
For what it's worth, I think that's the only way this can possibly be made to work, is to be like the fast path, slow path thing. I mean, it's unfortunate. I don't disagree with that. So maybe like I'd like to suggest a way of going forward here. First of all, like I haven't heard anybody say they don't think this is something interesting to do. So I'd love to see like the working group sort of make some sort of soft decision to like move forward with this general thing. And then we'll have an opportunity to argue about whether or not, you know, the big Indian or little Indian and the Sarlacc pit and whatever. What I would suggest as far as the so I asked the chairs to do something along those lines. With respect to the specific technical question of exactly how that the terminal you know, signed object is formatted, it might be interesting to sort of to scope out exactly what possible things you might imagine saying in that doodad, right? So I mean, for the perspective of so I think that we have these, you know, we have these these two versions which require PKIX, right? And require somehow screwing with the either taking, you know, using basic constraints and then using your ordinary validator, or somehow screwing their validator a little bit to make it accept as EKU. And then we have another one which is like basically we're going to invent some new, you know, rump certificate format that we use for this. And I think one way to potentially resolve between those last two, between this first two classes and the third class, would be try to write out all the possible things you might want to say in this like well, new certificate format you just invented, and then convince yourself that it's significantly less complicated than 509 at that point. And I sort of initially rose to say I'd like to have seen an extensions block in that doodad. So I guess my intuition is that by the time you've done that, you will discover you've largely reinvented X509 and that you wish you just to use 509. But I could be wrong. So my suggestion would be to maybe try to do a short requirements exercise where you try to actually map out all the possible things you might want to say, and then see if you still feel, and see the people who feel that they don't want 509 still feel that way. I personally don't feel particularly strongly in any case. I'm not the person who's going to have to eat this on the fire.
I think we'll close the lines after Ben.
All right, Leif Johansson. So I don't have a dog in this fight, but I just find myself coming up to +1 echo. And also to say that, to underline a point that Russ was making earlier, that the proxy certs have seen fairly large-scale deployment in certain communities, the e-science community, for over 10 years, right? There's a lot of implementation experience. There's a lot of deployment experience, not only for server side, but also for mutual authentication, right? So this stuff is fairly well known, right? And it is fairly well deployed and understood in certain communities, right? I understand that there's almost no overlap with this community, with that community, because they're physicists, and I'm usually the first person to mock physicists' ability to actually run IT, but there there you are. I would definitely think long and hard about exactly what you need to add to this strawman idea before it's useful, and then convince yourselves that you've actually achieved some level of increased simplicity over what X509 or proxy certs already give you. Yes, OpenSSL does proxy certs and have for a long time.
Oh.
Comment from Rich Salsey wants to kill it.
I think what we want to do is just take a quick hum to make sure we have interest on this topic. I mean, this is something we've been discussing for a little while. So 2 questions. Just one, do you want to see the working group continue investigations in a delegation? And 2 would be, you think that it's a bad idea for the working group to pursue this. So please hum if you believe the working group should continue investigations into delegation. Please hum if you think that this is a bad idea. All right.
We can hum for both, can't we? Yeah. So my question then is this a document we want to adopt?
That's the next question.
Oh, okay. We should ask that question as well, because I think that absent the discussions about endianness, the document's covering the right concerns. It's the only thing in existence. We could adopt it.
How many people have read the document?
That's not a lot, unfortunately. So I think we definitely encourage people to read it on the list, and then maybe early in the new year we can do a call on the list. So again, take a read. If we're going to start doing this, you should all be interested. Great, you're on.
Good morning. So I'm going to go to look at certificates in TLS from a different perspective. Next slide, please. We've had a problem with misissued certificates for a while. People are doing certificate transparency today, and I'm going to talk about something that is essentially an alternative, and I'll go back to how this interacts with certificate transparency later. But first, we have had certificate pinning standardized for a while. that's work by the WebSec group, and essentially it hasn't been implemented. There's actual statistics, very small numbers of servers that do certificate pinning according to the standard. People are doing their own certificate pinning. Google is doing that for their servers. Mozilla is doing that. We've had security vulnerabilities associated with this do-it-yourself certificate pinning. So it's an interesting area. So I'm going to talk about a different TOFU approach to pinning, and not actually certificate pinning. It's something we call identity pinning. Next. So instead of pinning to the actual certificate, instead of the client being aware over a long period of the server certificate, what we propose is that the server and client share a secret for a long duration. One shared secret per client is obviously not scalable on the face of it, but if you move the responsibility to the client with tickets that are similar to session resumption tickets, that suddenly becomes a possibility. This is all done at the TLS level, unlike HPKP, which is at the HTTP level. So this is generic to other protocols using TLS. And the current proposal is based on TLS 1.3, and we have a prototype implementation as a fork of the Mint TLS 1.3 library. Next. So what happens on the initial connection is that the client requests a ticket from the server. The server generates a ticket that contains the protected, so encrypted and integrity protected shared secret, contains it. The server sends the ticket to the client. The client in parallel can compute the same shared secret. So the client saves the ticket in its ticket store and also saves the shared secret itself that it computed. The ticket is obviously time limited. Just as an example, think of 30 days. So the server's identity is pinned for 30 days, which means that if in the next 30 days I see a server that does not understand the ticket, I know that the server is probably, so a server with the same name, I know that the server is has probably been misissued a certificate. And so it's not the right server. Okay, next. So whenever the client connects again to the same server, same as defined by name, the client sends the ticket to the server. If this is the correct server, the server can decrypt and validate the ticket. It can compute the shared secret that was stored in the ticket, and so it can prove its knowledge of the shared secret to the client. And the client knows that this is the correct server. While doing it, while computing the proof is actually also bound to the current certificate presented by the server to avoid some types of man-in-the-middle attacks. So again, we're not pinning long-term to the certificate, but still the server is proving that it's using the same certificate. So it's binding the certificate that's being used for the TLS handshake with the proof of knowledge of the ticket. Unlike some of you may be familiar with the TAC proposal, TAC was using public keys, whereas this is only using symmetric keys. TAC was also relying on the TAC pinning, the TAC pins, to fully authenticate the server. We're not. So this can be considered second factor authentication for the server. You need the second factor to succeed, but it's not sufficient. You also need normal certificate of authentication of the server. Next. Similarly to session resumption tickets, you have one big protection key on the server. It's only one key, meaning it's scalable and it's easy to share among servers in a cluster. It's also quite easy to rotate. You include the key ID with the ticket, so you can rotate the protection keys asynchronously. It doesn't need to all happen at the same time. And not too difficult, and similar to what we have today when people do ticket resumption. Again, this is not certificate pinning, so the server certificate can be renewed, can even be revoked, and this is unrelated to people having those tickets in their ticket stores. We also have a facility for ramp down. So, like I said, if the server hands you a ticket for it, it means that the server commits to understand the ticket for the next 30 days. Otherwise, you will refuse to connect to it. So if the server decides at some point that it doesn't want to use this facility anymore, it can still understand outstanding tickets, but not issue new tickets. This is ramp down mode. And at the end of 30 days, you can stop using this facility and you don't find yourself with a host, with a bunch of clients that refuse to talk to you. Next, please. So we presented this proposal on the list. There was a little bit of discussion. I'm not proposing this draft to be adopted. I would like to the working group to be aware of it, to review it. And then once TLS 1.3 is out, we will probably ask for adoption. Questions, comments?
Yeah, Yaron has been very nice in holding off, inundating us with requests for a working group adoption while we're working on 1.3. So we as chairs appreciate that. Ryan?
Right. So Ryan Sleevey, guilty as one of the co-authors on the HPKP draft, at least is claiming that. But so one of the things, Google has done a lot of outreach on security features like CSP, HSTS, HPKP, reaching out to site operators to understand concerns. Why are they using features, not using features, et cetera, right? We want to make a more secure web. So one of the concerns, the biggest concern that we've heard from HPKP is not the concern that is limited to HTTP only. It's actually the concern that this is a key lifecycle management issue. It makes key lifecycle management failures fatal. In particular, HPKP allows you a very expressive policy to set up what keys you want to bind to. But then if you lose those keys or you can't get a new certificate with one of those keys because the CA browser forum has changed its rules, et cetera, you're kind of in a bad place. This doesn't seem to address, it seems that this proposal has that same fundamental problem, that a failure in key lifecycle management becomes a fatal operation failure. And from seeing things like Let's Encrypt, part of their model is we assume site operators can't manage their keys well, so we're just going to keep turning around keys often to make it easier. So I guess I'm suspicious of more drafts that don't try to address this. HPKP tried to address this in its insufficient form by saying, well, pin to the CA. And that way, even if you lose your keys, hopefully the CA doesn't lose their keys. You still have the risk of the CA failing, but you can get a new certificate with a new key in and continue operation. Is there any plan for, how do you recover from this in a failure mode?
Yeah, so so there's actually a section about comparison with HPKP in the draft. Please take a look. My view of this comparison is that it's not, or not only, about the key management. It's a lot about manual operation, and manual operations being error prone. In the case of HPKP, in most of the real enterprise world, at least up until Let's Encrypt, and probably still today, much of the CA, so certificate renewal and regeneration of the pins will happen manually. This is not the case for this proposal. I think that's the main difference. So yes, the protection keys still need to be backed up, otherwise you're screwed. That's true. But I think there's much less risk of it because it's all automatic.
So Ben Kaduk, it looks like I only read the 01 version of the draft, so maybe things have changed. But 2 points. One is that you have potential privacy considerations if the client is reusing the same pinning ticket, which I don't remember if you talked about. The other is that you even acknowledge this is very similar to session tickets. And so my question is, what value do you get from this that you would not get from just relying on TLS session tickets and saying, if the server rejects my resumption attempt with this ticket, I will do the same thing that I would do if the pinning ticket validation failed?
So let me start with your second one. I cannot, so if the server is misissued a certificate, I cannot rely on the server's correct operation with respect to session tickets. So yes, a correct server would reject my session ticket, but that's obviously not a reason not to connect to it. The server is not obligated to accept my session resumption ticket.
Right, but if you knew that the server was operating in a way that had the property you want,
that
it will always honor session tickets that it has validly issued within their validity period.
So I'm maybe missing something. I don't think a correct client can expect the server to always honor a session resumption ticket. Something might have happened. The server might have lost its protection key, and it's still valid.
Yeah.
So it's a different behavior.
The management requirements for the session ticket encryption key and the pinning ticket encryption key seem basically identical, especially with your clustered environments and
correct.
Not forgetting it. So it seems so similar to me that I have a hard time convincing myself it's adding substantial value. And maybe it's just
similar, but it's similar to session resumption. Obviously, it's inspired by session resumption, but it's different in its security properties. And actually, the subtle points about about key management for those protection tickets that that differ between session resumption tickets and these ones.
Also, timing is quite different. Session tickets, you have typical 5-minute expiration, and I think you're proposing 30 days.
Yeah, but let me go back to Ben's first question about privacy. So, two answers. One is the draft includes a way for you to ask for, or actually the server is, we recommend that the server return you a new ticket upon each connection.
Right,
so an observer, a passive man in the middle, will not be able to associate a ticket from time 1 to a ticket from time 2. As to reconnecting to the same server, there's no guarantee of privacy in that case.
Dan York, as I read the draft and looked through it, I have 2 comments on your security considerations part. One is on the tofu part of things. One thing I would encourage you to look at is, or to mention in there perhaps, would be the fact that if you do have a DNSSEC, if you're doing a DNSSEC check, not DANE, DNSSEC, just for the IP addresses of it, you can know you are connecting to the correct server if the server is signed, obviously, if the records for that are signed. If you do that, you would know then that you're connecting to the correct site. My second comment is in the part where you talk about the issue of connecting to the wrong server and winding up pinning the certs from an attacking site. I think there needs to be something more there with guidance around what you just say that the service provider should let customers know how to unpin the corrupted pins, but I think there should be a bit more in there about what how they would do that.
Yeah, I agree.
Okay, so thanks everybody.
Just one last word about CT, because I promised. So if and when certificate transparency completely solves the problem of misissued certificates, we would not need such a solution. So maybe it'll happen within the year, maybe not. Some people are obviously hoping that CT will happen late in 2017. Even if CT happens, we will probably have a hole around so-called private certificates for enterprise deployments, where people are not crazy about having their certificates published to the whole world. So I think in that scenario, identity pinning is still valuable. Thank you.
Yeah, thanks. Just for out of curiosity, show of hands, who's actually read the draft? Okay, couple. All right, cool, thanks. And I think that pretty much wraps it up. The one person we would like to see though is David Benjamin before he runs off. Yeah, privately after, just quick. Nothing bad, we just wanted to make sure you didn't run away.